Hello, welcome to the next part of programmable logic devices. In this part of the lecture, we'll try to understand what is programmable array logic, that is famously known as PAL. Let us have a look about the internal structure of PAL. Here we can see that the and or structure, which are very similar to the other programmable logic devices, but here the and array is programmable. Here on the left hand side we can see it is the and array which is actually programmable. Here the cross means the fusible links, but on the right hand side we can see the or array has been hardwired. So each OR gate is hardwired to 4 AND outputs. So if we just consider the top 4 AND gates, that is 1, 2, 3, and 4, the outputs of the outputs of this particular AND array is connected to O3. Similarly, if we look into the next part, the AND gate 5, 6, 7, and 8 are connected to O2. Similarly, 9, 10, 11, and 12 are connected to O1. And 13, 14, 15, and 16 are connected to O1. So if we try to say if we try to program only O3, and let us take an example here. The example here is we need O3. Output will be a dot b or c bar dot b bar. So this is the output that we are expecting from the OR gate 3, the output O3. Now I have just simplified this particular circuit. I haven't shown the entire structure. I have just simplified it, and I'm just concentrating on the output O3, which is hardwiredly connected with the output of AND gate 1, 2, 3, and 4. On the other side, we have the AND array, which is actually having both, that is the normal variable as well as the complemented variable. What we have to do is we have to select those which are required at the input of the OR gate. So if we choose the AND gate 1, and the output of the AND gate 1 will only give out the mean term a dot b. Now if we can initially think about the structure where all the inputs were fused, all the input fusible links were available. So we also had D and D bar at the input of the AND gate. Also we had C bar at the input of the AND gate. Again B bar at the input of the AND gate, and A bar at the input of the AND gate. It is the same, or it is the same for all the inputs of the AND gate if it is in the initial configuration, that is before we have programmed it. So here, if we want the output of AND gate to be A, B, and we don't want C or D or any other combination, then what we have to do is we'll have to remove the fusible links from others and only allow B and A to be the input of AND gate 1. Similarly, if we have to take C bar dot B bar from the output of the second AND gate, then again we'll have to allow only D bar, which is from here, and C bar, which is from here, to enter into the AND gate. Obviously the output will be C bar dot B bar. But if we talk about the other two terms, there are other two terms which are hardwired with the OR gate, we have to have a 0 coming out of AND gate. Now we all know in a pre-programmed configuration, all the inputs are available at 3 and 4 AND gates. So what we will do is we will leave that as it is. So what it will create at the input is A bar dot A, B bar dot B, C bar dot C, and D bar dot D. So what we can see is any one of the input will definitely be 0 of the AND gate. So one input, any one of the input at the input of AND gate is 0, then the output will definitely be 0. So from this two AND gates, that is the output of this two AND gate, that is 3 and 4, we will get two zeros. So the output of O3 will be A dot B or C bar dot B bar. So this is how we program a PAL using the simple logic we have learned from the previous lectures on programmable logic gates. So thank you for watching this video. I hope the video was informative regarding PAL and the programming technique. Thank you very much.